What is a piecewise function and how we can evaluate it? A piecewise function is defined piece by piece by piece. It is a function defined by many different functions, many different expressions over multiple different intervals. A function defined by many different expressions over multiple different intervals. How we graph and evaluate piecewise functions is our focus for the week. It's chunk by chunk by chunk. A function broken up into different chunks, piece by piece by piece.
Kylie Rainey, please report to the secondary office. Kylie Rainey, report to the secondary office.
Sometimes I think about piecewise functions as an if-then statement. If this is true, then plug your number into this. If this is true, then plug your number into this. So we're going to evaluate and find f of negative 10. That means plug negative 10 in for x. F of negative 10 as notation means plug negative 10 in for x. The math behind our lesson today isn't very hard. It's just mostly understanding what the notation means. So f of negative 10. Is negative 10 less than or equal to negative 10? Is that a true statement? Is negative 10 less than or equal to negative 10? Listen, you said yeah, right?
Yes.
So if that's true, we're going to plug negative 10 into this expression. For any x value that's less than or equal to negative 10, use this expression to find your answer. Plug negative 10 in for x, x squared minus 5x. What's another number that's less than or equal to negative 10? What's another number that's less than or equal to negative 10?
Positive. Oh, wait.
Positive 10 is greater than that, wouldn't it?
Negative 11.
Negative 11. Is negative 11 less than or equal to negative 10? Yeah. So just like negative 10, you would plug negative 11 into this expression to find your answer. How about negative 7? Is negative 7 less than or equal to negative 10? It's more because it's closer to 0, right, Kennedy? So negative 7 is not less than or equal to negative 10, for example. We have to look elsewhere in our function to know what to do with negative 7. Let's look at the next row down. Does negative 7 satisfy this inequality? This is a compound inequality. It's two inequalities put together in one. X is greater than negative 10, and at the same time, x is less than negative 2. In other words, our x values are always less than negative 2 and also greater than negative 10. Does negative 7 fall into that category? Is negative 7 between negative 2 and 10? So we would choose to plug negative 7 into this part of our expression.
Where's the 19 come from?
What do you mean by 19? That's just what number I gave. It could have been anything here. Take your x coordinate and add on 19 to find your answer.
Well, why do we add 19?
That's just the example I made up.
Oh.
Okay. Why is it a minus 5 right here? You know, it's just that example I made up. Let's try another one. Let's try 0, for example. What do I do with 0? Is 0 less than or equal to negative 10? Is 0 more than negative 10?
Yes.
Okay, is it less? I'm sorry, so it's not less than negative 10, right? Is 0 between negative 2 and negative 10? So 0 doesn't work here, 0 doesn't work here. Is 0 more than negative 2?
Yes.
So if I had to plug in 0, I would do it into this expression. These intervals over here help you figure out which expression to plug your number into. We're going to take negative 10, negative 4, and 1 and figure out which of these rows to plug our number into to find our answer. So we'll start with negative 10. Is negative 10 greater than negative 2? Is negative 10 between negative 10 and negative 2? Is negative 10 less than or equal to negative 10?
Yeah.
So we're going to plug negative 10 into the top row. Change the x to negative 10. So it's negative 10 squared minus 5 times negative 10. To find the value of f when x equals negative 10, we're going to plug negative 10 into our expression x squared minus 5x. What's negative 10 squared?
5.
What's negative 10 times negative 10? Because negative 10 squared means take negative 10 times itself twice.
Negative. Positive.
Is it positive or negative? I like the 100. Is it positive or negative?
Positive.
Positive, because doesn't two negatives make a positive when you multiply?
Wait, when two
Right?
negatives
Multiply
make
the next
positive?
part. Two negatives make a positive when you multiply.
The two's,
A negative times a negative make a positive.
the two's negative though?
You have two different negatives to multiply together. A negative 10 times a negative 10, Sophia. It's two different negative numbers multiplied together, so it has to make a positive. Multiply the next part. What do you say, Tori? Negative 10 times negative 5.
50.
50, good. Positive 50. Now add them together.
150.
150. All we're going to get is just a number. Function f has a value of 150 when I plug negative 10 in for x. I knew to plug negative 10 into the top row because it satisfied this inequality. Let's check the next one. Where is negative 4 going to go? The top, the middle, or the bottom?
Middle.
Say again, Garrett? Middle. Well, okay. Not the top. Negative 4 is not less than or equal to negative 10. It's more than negative 10. It's negative 4 between negative 2 and negative 10. You bet. So let's plug negative 4 into this expression. Negative 4 plus 19. To find the value of f when x equals negative 4, plug negative 4 into x for x plus 19. Negative 4 and 19 combine to make what? 15, it's just 19 minus 4. That's 19 plus 4. This is 19 minus 4. All right, just by coincidence, I think I went down to f of 1 next. F of 1, where I plug 1 into, top, middle, or bottom? Bottom. Doesn't always have to go in that order. I just went numerical order here, so it's going to go in numerical order up on top. That just happened by accident. F of 1 is 1 greater than or equal to negative 2. What do you say, Caleb? Is that true? Is 1 more than negative 2? Yeah. So since it worked here, since it satisfied this inequality, we know to plug 1 into that expression. We'll get 1 to the third divided by 1 plus 9. Katie, what's 1 to the third? 1 times 1 times 1. That's 3 times 1, not 1. It's not 1 plus 1 plus 1. It's 1 times itself 3 times. 1, very good. 1 to the third. 3 ones multiply together to make 1. What's 9 plus 1 for the denominator?
10.
10, 1/10. All done. 1/10 or 0.1 as a decimal. In a piecewise function, these inequalities help you determine which of these formulas to plug your number into. That's pretty much it. Let me slide over to number 2. What's different about this guy? It's got some infinity, right? It's also got this symbol. Notation is a little bit different over here. We got some different notation to understand. Rather than inequalities, they give us what is called interval notation. It means roughly the same thing. This symbol means between or within. X is within negative infinity to 0. This is an interval. Negative infinity is as small a number as you could possibly imagine, all the way to the far left on a number line. Negative infinity to 0. That's negative infinity, as small as you can imagine, up to and including 0. This bracket right here means including that right endpoint. From negative infinity to 0, including 0. If you want to think of it as an inequality, imagine it as x less than or equal to 0. It means the same thing. from negative infinity to 0 means all the numbers that are left of 0 on a number line. All the numbers that are less than 0, including 0, is sum. For example, on the next one, x is within 0 to 8. That's all the numbers between 0 and 8. Would I include the 8 in that interval? Does 8 have a bracket just like the 0 did up above? So it's including 0. What is different is that the parenthesis is on the 0 on the left endpoint. This means excluding. Which should make sense. If I included 0 up here, I can't include it down below. I know just plug 0 in using this top function, not the bottom one. This is every number between 0 and 8, including 8, but not the 0, including the right endpoint, but not the left. All possible values between 0 and 8, but not 0 itself. As an inequality, that means that x is less than or equal to 8. At the same time, x is greater than 0. What if I changed it to look like this? I put the bracket back on 0. How would I change my inequality over here? Add an equal sign, right? Because I'd have to include both endpoints, both the 0 and the 8. That parenthesis on the 0 means I can't include the 0 as a part of that interval of numbers. Describe what this means then. X is within the interval 8 to 9. What does that mean?
It can be equal to.
Is it equal to, Ava?
Wait.
Does this include
No,
8 and 9?
it's not.
It's in between, but including neither endpoint, right? Excluding both of the 8 and 9 themselves. So as an inequality, we've got 8 and 9. X is between 8 and 9, but excluding both endpoints. Neither of the two values, 8 and 9,
So like
are
eight
part of
and
that
a half?
expression. 8.5, 8.75,
Okay.
8.01. Any possible value between 8 and 9. Last one. X is within 9 to infinity. What does that mean? Just like negative infinity is all the numbers that fall to the left, positive infinity would be all the numbers that fall to the
Anything higher than that.
anything higher than that, like Kennedy said. From 9 all the way up as high as you can go. From 9 to positive infinity. Do I include the 9, Kennedy?
No.
No, because why? What notation tells you that?
The parentheses.
Parentheses rather than the bracket from up above on these previous two lines. X is greater than 9. Let's look at a couple ones here. We've got to find the value of h for a bunch of different numbers. -3, 10, 8, and 4. But which expression do I plug those 4 numbers into? Those intervals on the right column should tell us that. Where is -3 going to fall?
Top one.
1, 2, 3, or 4. Which row?
Top
Top row. Isn't -3 within the interval negative infinity to 0? All numbers that are basically less than 0.
Yeah.
So let's plug -3 into that expression x cubed. -3 to the third. That's 3 different -3s all multiplied together.
So we negative 9.
-3 times -3 times -3.
Oh.
Is that a positive or a negative?
So-
Be a negative.
Because there's an odd number of negatives. An odd number of negatives multiply to make a negative number.
So be
What's 3 times 3 times 3?
Negative.
That's 3 times 3. Take that 9 times 1 more 3.
Negative 27.
27.
-3 times -3, make the 9 you told me, Sophia. Another -3 turns it into -27 for our final answer. Where's 8 going to go? Is that in row 1, 2, 3, or 4? I see a couple different 8s. It's obviously going to be either the second row or the third row. Which one includes the 8?
Second one.
Second one. Why are you saying the second one, Caleb?
There's a bracket.
The bracket. This is all numbers between 0 and 8, including the 8. So if I have to plug in 8, it's got to go here and not here. Does that make sense to everyone?
Mm-hmm.
Why pick the 8 going into the second row? Okay. 8 is going to go into this expression, 24 divided by x. Let's replace that x with 8. 24 divided by 8 minus 1. You said 3. Here it said 24 divided by 8 is 3. 3 minus 1 is 2. Make sure you follow order of operations there. Try those next two. 4 and 10. Substitute 4 into your function, substitute 10 into your function. Let's see what you got. You put 4.
Yeah, what does that mean?
What's -7 by
It just says -7 for the last.
That means you're only going to get -7. For any number between 9 and infinity, it's always going to be equal to -7.
Where do you see that?
Yeah, but how do you plug in?
You don't plug anything in. It's always just -7. The answer is independent of x. For any value between 9 and infinity, the function is always going to return -7.
So is the answer just -7?
Which row again?
Let's see, yeah, to that, yeah.
4 is between 0 and 8. So
Yeah,
you're
it
plus
says
4
-7.
Just like 8, plug 4 into 24.
Just give us an
So 24 divided by 4 is 6. 6 minus 1 is.
Did you plug in the
I
four?
put in 42.
Yeah. Oh, so you can do the same. You can do the same problem twice.
Which one? Which row? What's this last one? The only thing we have on that last one is just -7. No matter what, for any number between 9 and infinity, you're always going to get out -7. You're going to plug it into, right? It's like for any x value between 9 and infinity, the function is always equal to -7. Done. There's no work to do.
-7.5.
You got
Try
5?
it. From
what?
Hold on, because you plug it into number say 2. You plug in h into number 2. You do it from there. So you got 24 over 4. 24 divided by 4.
So it's over 8.
24 divided by 4.
Oh.
Garrett, you might be wrong.
Garrett, yeah, I think you're wrong.
No, he's not. He's right. He's right. He's right. He's right. He's right. He's right.
Besides 2. I don't know.
He's right. He's right.
So what was it? -5?
24 over 4. So what's 24 divided by 4?
A little bit over 20.
What? 24 divided by
5. What is it? 6.
minus 1.
What?
Think of
-5?
5. Muy bueno.
Yeah.
Is 10 within 9 with 10? For any x value, 9 with 10, our function is value -7.
I can go for this right.
There's nothing about it, it's just, here's your number. It returns out
For
-7.
men, it's $10 a pop.
How do you look at your group?
I only did 4.
Okay, how about 10? Which row? The top, second row, third row, or bottom row? Bottom row, I agree, because isn't 10 in one line?
I know that.
So, the only thing our function gives us
Good.
for any x values between 9 and infinity is just -7. That's your answer. There's nothing to plug x into, right? For any x value between 9 and infinity, your function's always equal to -7. That's it. All right, let's talk about the last two here. I think we are doing good. It just takes a little bit of practice and making sure we're doing order operations correct. Which interval does 4 fall within?
Two.
Row 2. 4 is within 0 to 8. 24 divided by 4, minus 1. That's 6. 6 minus 1 is 5. Good. I think everyone got that one just about right. The next one's a little bit tricky because we have to use the bottom row. 10 is within the interval 9 to infinity. For any x value within 9 to infinity, our function's always equal to -7. That's kind of different because there's nothing to plug x into, right? It's just, here's your answer, you're done. This is -7. That's it. For any x value from 9 to infinity, our function returns a value of -7 always. Questions you guys had on those practice problems? Okay, then